Okay, it's 1 o'clock. Everybody's commenting on the room, so I guess multicast is a hot topic, although I'd like to see a few more people here. So the session you're at is BRK ENS 3850 on demystifying multicast operations in a multi-site SDA deployment, which is a mouthful. So my name is Jeff Hoke. I'm a systems engineer or systems architect. I know most of you usually see people, TMEs, present. Been with Cisco for coming up on 20 years now, based out of Hershey, Pennsylvania, where you can smell chocolate every now and then in downtown Hershey. Been doing a lot of work with transportation, and the presentation is based on a transportation customer, and one of my customers is actually in the room here. I'm not going to put him on the spot. And CCIE for over 20 years. Hobbies are skiing, cycling, and golf. And I have Rashmi here that I'd like to have her introduce herself.
Thank you, Jeff. Hey, everyone. My name is Rashmi Rao. I'm based out of RTP in North Carolina. I've been with Cisco for 14 years. All of those years have been customer-facing. I started off doing service provider migrations and then moved over to enterprise a few years ago. And currently, I support SD access deployments for various customers and various sectors. I'm a CCI in service provider, and my hobbies, I read books, a lot of books. I like to watch TV, and when I do get the time, I like to travel to new places. So the picture that you see up there on one such trip, you might be thinking I do a lot of driving. I like to drive, I know how to drive, but I'm not allowed to drive because my husband says I off-road a lot, so.
So a couple of housekeeping items. We do have some moderators in the WebEx space. So if you do have questions, go ahead and put that in. And actually, one of our deployment engineers for this customer, where we based most of this presentation out, is in that space as well as some technical marketing folks as well. Like I said, we're deployment, pre-sales, engineering. We don't know roadmaps, we don't know features. I can, if there's something you need, put it in the space. We can use that as leverage of, hey, I've run into this issue as well. That would be quite helpful. Also, before I start, I did notice I have some hidden slides, and I'm not going to present on those, so there might be 7 or 8 slides that you're seeing from the PDF. If I jump over them, I'm not omitting them. They're just more for your reference, and we want to focus more on the deployment than just multicast and like how it works and things like that. So the learning map, have most of you done this track? Have you been through the track? We are at the last session on the last day. Has it been good? Everybody, yeah? Lots of things. You're excited, going to go back and deploy SDA and turn multicast on and everything? I mean, that's really our goal, is to get you comfortable. There's been some good sessions on Lisp that Rashmi and I attended, and can see a lot of benefits behind that. So like I said, I'm a skier. I know you're multitasking, you have other screens in front of you, so I like content, I like configurations. As an engineer, as a customer, I like that configuration snippet. DNA Center is hiding a lot, right? So we're trying to reveal, what is DNA Center pushing? What is it not pushing? What do we have to do from a template perspective? So we're going to give you that. We're going to give you a roadmap book type thing today where you can go back and be like, hey, if I do this, I can successfully get multicast deployed. So you're going to see slides labeled as beginner, intermediate, advanced, expert, based on the configuration, based on packet captures where, hey, oh, there's an advanced slide up there, I better pay attention to that. Maybe I can just ignore the beginner slide. So one of the things about skiing is if you don't know, you don't go, especially when you go backcountry, being a skier, or you provide a guide, right? So we're here today to try to provide that guide. So real quick, you guys and gals could probably do the SD Access recap by now, I would think. I'm going to try to do it in 3 slides. You've probably seen this before. I've been to sessions this week and see the same thing. Then I'm going to go into IP multicast, right? I'm going to do a quick recap on ASM, SSM, rendezvous points, things like that, just to set the baseline, because multicast is one of those things that you might not have to troubleshoot for a couple months, and then you have to jump back in. So I want to make sure that we're all understanding that, what's available in DNA Center. I'm going to talk briefly about head-end replication, briefly. There's other sessions out there that went into head-end replication. For this particular customer, we did not use that. We used native multicast, so I'm going to spend most of my time on that. And then I'm going to talk about multicast design considerations, what to think about, how am I going to integrate this? Is this an existing deployment that's out there that I have to implement multicast with in an SDA fabric, or is it a brand new greenfield deployment? Then I'm going to turn it over to Rashmi. We're going to talk about the customer and the design and some of the limitations that we found, and give you those config snippets and those templates and stuff that we use to make this work. A new release just came out 2 weeks ago. Lots of multicast enhancements in it. We are not running this release, but 2.3.5.3, which is the GA, its internal name is Ghost. It's one of those things where my customer is in a public safety network, so we need a gold star release. So we just couldn't upgrade and go to Ghost and get a lot of these features. But over time, we definitely will do that. Talk about key takeaways, and we'll conclude, and we'll get you out of here and off to hopefully safe travels. So SD Access recap. 3 slides. Underlay networks, right? Overlay networks. I think every session I've sat in so far has had overlay, right? Who's running SD-WAN, right? Overlay network. Who's running CapWAP tunnels? Overlay network. SDA, overlay network, right? It's just ACI, overlay network. I've been doing this for 20-some years, and there was never such a concept, right? So understanding overlay and the benefits behind it are key. Scalability, mobility, segmentation, right? There's a lot of good benefits to it. Building tunnels, using VXLAN encapsulation to do that, right? Hopefully some of you have taken some list sessions today. There's some benefits to reducing the IP churn with mobility. Some key concepts, terminology. You know, obviously the DNA Center that we were running is 2.2.3.5. That was the gold star release. We did upgrade to .7. But DNA Center with this customer, like I said, they're a transportation, they're a roadway, they're building a network on a roadway. This isn't a college campus. This isn't your 5 buildings coming back to a data center. This is a roadway network that we deployed SDA on. So automation is important to them. They're going to have hundreds, if not thousands, of switches over time. They have tens of thousands of IoT devices, endpoint devices, phones, cameras, anything that's IoT-based, and it's going to grow with things like CV2X and any sort of sensor that they have on the network. So automation is key to managing this. We have what's called a fabric border node, which by now probably everybody knows that's the entry-exit point to the fabric. We have fabric edge nodes where all your wired devices connect to them. We have intermediate nodes that are just under a site, but they're not fabric enabled. They're just pure routing. They don't even have to be within DNA Center. They could just be pure switches that are out there that are just forwarding, and that's the beauty of overlay networks. And then we have the control plane, which is the brain of the operations. That's maintaining your mapping cache, mapping databases with Lisp, and that's what, it's a pool technology, and that's where you get all your scale and your benefits. So like I said, we use our control plane as Lisp. And basically, it's like DNS, right? I need to take a URL and look up an IP address. So in this case, I need to find an endpoint, and what's the remote location of that? Send me the endpoint information, whether it's IPv4, IPv6, MAC. Send me the RLOC address, so I can tunnel that across my network. VXLAN adds additional 50 bytes, so MTU is something to consider. Service providers. So when you're looking to build an SDA network, you need to understand what your service provider network look like. Can it support jumbo frames? I just was in a session about an hour ago, and they still want jumbo frame support. I would say if you can't get that, and you can do like maybe 2,000 bytes, talk to your local account team, go to something called an SDA council and see if you can get that approved to do that. There should be no reason why a 2,000 byte MTU can't work, but everybody just keeps saying they want jumbo frames. And then the policy plane, we definitely implemented ICE. We definitely implemented TrustSec, but this is going to be focused more around multicast. So everybody's probably heard about SGT and VNs out there and how VXLAN headers transport them. Deep dive sessions. Lots this week, lots from Amsterdam. You can go out there and go deeper into SD access. So that's my SD access in 3 slides. IP multicast. ASM, SSM, RP, MSDP, right? All these different 3-letter acronyms. ASM, I think of like any size moguls, right? Or SSM, maybe small size moguls when I'm skiing. But that's not what it stands for. So we're going to go through some multicast routing terminology. So we have a source. It's somewhere in the network, right? Is it in the fabric? Is it outside the fabric? In our customer case, it was everywhere. It was in the fabric, outside the fabric, and we had to be able to handle that. We have a receiver, same thing. In the fabric, outside of the fabric. We had sources that became receivers because they were IP phones. Then there's the concept of first hop router. That's the device attached to the actual source, and that can change based on where the source is. The last hop router is the device attached to the network segment of the router. And then the devices in between handle the control plane, handle the replication. They're your mRoute tables. And then we have something called rendezvous point. And that's got to do with the shared tree. So there's this concept of shared versus source tree. And if the device doesn't know where the source is, basically it's any source multicast. I have a receiver, I need a stream, I know the group address, but I don't know how to get there. So that's why we need an RP. It's kind of a meetup place. All 3 versions of IGMP are supported, but if you're running IGMP version 1, version 2, so you're gonna have to look at your endpoints. So understanding what's my endpoints out there from a receiver perspective is gonna dictate what you're gonna run. Most likely, you're already running ASM out there. Is anybody running SSM before you even get into that? Before I talk about that? You are? All your endpoints support SSM? No? Okay. So I'm looking for one of those because we'll talk about that briefly, but that's like the utopia, right? So you don't need the rendezvous point. So we need to learn how to connect the receiver to the source. And that's really what a rendezvous point does. So let's look closer at this. So like I said, there is a shared tree, or RPT, rendezvous point tree, and then there's a source tree. And one of the things we're going to talk about with this particular customer is they have configuration that does not allow that cutover to go from the shared to the source tree. And it's got to do with a paging environment. They use an application, remember iPix back in the day? Now Instant Connect, those guys were actually there. We sold the product off and I actually saw them there. So that you can have delays in paging networks from you cut from a shared to a source tree. And so there's a command that we're gonna show you later on that prevents that from happening. And configuring that in an SDA environment was quite the challenge. So how do the multicast devices agree on who's the RP? If the RP fails, how do we have redundancy? How do we do that? So there's a couple ways to solve this problem. One is auto RP, which my guess is probably a lot of you are running out there that you've configured. It's kind of the old way of doing things. And it's basically using a mapping agent in Canon RP. And it uses the multicast addresses that you see up there of 224.0.1.39 and 40. So it's going to flood. Remember that PIM sparse dense mode command? So it can flood and then kick over to sparse mode. That's probably configured out there. Or you can statically configure it, or auto RP listener if you want to flood on sparse mode interfaces. Kind of the old way of doing things. Then BSR, or bootstrap router, kind of the same concept, but vendor interop. It uses PIM hellos to exchange the RPs. Anycast RP, right? We've been talking about anycast gateways all week. So that's the new concept, right? That's a smarter approach. We want to use anycast RP, and we want to advertise that RP IP address from multiple devices. DNA Center does static. Question?
Can MSDP run in the fabric?
Yes. Hold that thought, okay? So static, right? But DNA Center does automation, so I don't have to command line jockey going into all these things to configure it, right? I can use DNA Center to configure the RP, and we're gonna see that here in a second. So it's not as bad as it seems. So ASM with any cast RP. So here I have two RPs with the same loopback address of 1.1.1. I have a source that starts sending multicast traffic. So that FHR, that first hop router, sends a PIM register. It's actually unicast to the RP somewhere in the network. I don't have any receivers yet. So the RP is like, well, I don't know what to do with this, right? So eventually it would send a PIM register stop. But in this case, we're going to have receivers coming online now. Unfortunately, we have two routers here. The unicast PIM register went to the RP on the left. The traffic hit the DR on the right is going to the RP on the right. So it doesn't have knowledge. I don't have a star comma G, right? It went up the wrong side. So how do we deal with that? This gentleman back here, MSDP, right? Multicast Source Discovery Protocol. So basically, this is going to send what's called an SA, or a source active message, over to the other RP to let it know about it. So here comes our source again, back to the left RP, going the wrong way, right? It's equal cost multipath, so I can go left or I can go right based on some hash algorithm. I'm going to send that SA over to the other RP, and that RP has a star comma G entry. I have receivers, so I'm going to send a PIM join back to the first hop, telling that first hop router to update its outgoing interface and send me the traffic. Now, source-specific multicast, I know the group address, I know the source, it's all good, and I can just send that. It does have to be IGMP v3, not 1 or 2. And we actually use a reserved address called 232.0.0.8. So one of the unique things with SDA is when you do native multicast, you can do ASM or SSM in the overlay. We're going to talk about enhancement and ghost, but right now you got to pick one. So that's your first thing. Look at my endpoints. What can it do? Well, I got an IGMP version 2. Okay, I'm doing ASM. Maybe all my endpoints do IGMP version 3. I'm doing SSM. The big thing is I don't need a rendezvous point. So what does this look like? Source starts sending traffic. It hits the first hop router. The first hop router just says, okay, I don't have any receivers. I'm just going to sit there. Here comes the IGMP v3 message. Up the tree, we're building the shortest path tree, not the shared tree. It comes up to the first hop router, and then traffic starts flowing downstream. So I like to think of the shared tree of, okay, I'm at the top of the mountain skiing. Rashmi's new to skiing. You can take the shared tree down. It's the long way. It's the green route down. And I'm going to go down that double black diamond with moguls. Well, when you're skiing with moguls, it's tough, right? I feel like multicast over the past 6 months has been skiing with big moguls the size of cars. Lots of meetings, lots of work with CX, and we got through it, but yes. Any questions so far? That's my multicast primer. Like I said, if you want to know how ASM works on prunes and joins and how the switchover occurs, the thing to note with this particular customer, with paging, if you're seeing delays and you're seeing MRoute tables and aging out, and then you got to build the tree again, we're going to talk about SPT infinity threshold, right? That's the command to stop that from moving from shared to source. Head-end replication. I got 2 slides on it. If you want more detail on this, I'm going to refer you to a session that does a great job with it. This has been around since day 0, but basically what happens is the border or the first hop router, depending upon where that source is, it's going to receive a multicast packet, and it's going to basically copy that packet in unicast. So it's going to take the RLOC location of itself, that loopback address, and it's going to unicast that to every single edge node that has a receiver. Sounds like a good plan, right? What if you have 30, 40, 50 edge nodes? So every multicast packet is getting unicast 40, 50 times. It's a workload on typically what would be the border. Yeah, my pointer's barely working there. To all those devices. Now, where would I want to use something like this? Well, maybe my service provider doesn't support multicast. So maybe unicast would be the right way to go. So what does the last hop router do, or the edge device? De-encapsulates the VXLAN header and sends it right out to the edge device. Head-end replication does not rely on the underlay. It's easier to troubleshoot, but the replication is the downside. So when we looked at this, and we thought, got hundreds of switches today, could grow into the thousands of switches, source receivers inside the fabric, outside the fabric, source becomes a receiver, receiver becomes a source. No, we're not even going down this path. So we went right to native multicast. Put a couple links in there. That 2820 session is really good if you want to get into head end and how it works. You want to see packet captures on it and the replication, it's there. Native, like I said, it's more efficient. The replication's occurring at the intermediate node. We're going to spend a little bit more time on deeper dive on that. But it's more complex. It's harder to troubleshoot. I have SSM now running in the underlay, and I have ASM in the overlay. And it's not supported by all devices. Yes? Basically, when you do the overlay configuration, you're going to be asked one of the first things you do is head-end versus native. So you'd have to go back through the workflow. There would probably be definitely an outage on that, but DNA Center, we would definitely have to, DNA Centers, it depends, right? I don't know if DNA Center can just take off the head end and put on the native. There's commands that are on there, on the Lisp instances, that are different for native versus head end. It will do it? Okay. It took care of it? So the question, yeah, I'm sorry. The question was, like, if I'm head end, how easy is it to go to native versus, I don't think you'd go from native to head end. So DNA Center, always cautious if it's going to wipe things out or not, or leave fragments that are out there, understanding the configurations and what's out there. There's the 232 group mapping for Lisp instance, and then the other on head end, you just see PIM sparse mode. Pretty straight.
How do these systems handle passive receivers?
Passive receivers? Not sure exactly what you're... Okay. So no IGMP membership reports?
Yes.
You might have to statically get into template and statically join the group.
So we can still do that even in the SDA environment?
Yeah, LAN automation is not going to configure that for you, and even the overlay configuration is not going to do it. You'd have to do it in the template to do the static configs. In fact, when we were testing, we did that. And there's some sample configs of how we tested the control plane and data plane. That's probably what I would do there on IGMP joins. Okay. Okay. Native multicast. So we jumped in. There's this little button right here that says enable multicast. Well, that's simple, right? Automation. I've been doing this 20 years. I'm like, I don't like this. I want to see the CLI. So what does that do? Well, this is something to consider, right? We just did it, and it just configured multicast. And it does a great job, right? You do the peer device, it does MSDP, It creates, we're gonna see it here in a second. Like this, on the borders, it created MSDP because we had peers. It created this loopback 60,000 interface. Well, wait, I'm doing native multicast. Why do I have an RP in the underlay? I'm doing SSM, right? What's going on here? All devices, intermediate nodes, had PIM SSM default on, had my RP addresses and all the layer 3 interfaces, right? So if you do the peer, you get the MSDP, you get the RP, you get this loopback 60,000 thing. It's layer 2 flooding. It's not even used for the SSM. So layer 2 flooding isn't enabled by this, but it's setting it up to do this. There's another checkbox to do layer 2 flooding. So in our deployment, we needed to do RP mapping to group mapping. So as we did this, we're like, well, wait, LAN automation just broke, and we're going to show you a slide on that because it created the 60,000 and it's having all kinds of issues. So when we do LAN automation now, we don't check the checkbox. We come back with a template because we need to do RP to group mapping. And in our release, it didn't support that. So we'll talk about the enhancements that we could have used that are out as of 2 weeks ago in 2.3.5. So underlay config. So if you do check the checkbox, it turns on multicast routing. It turns on SSM. And if you try to configure multicast in the overlay and it doesn't work, make sure that SSM default, and that default command means it's the 232 RFC address, right? That's in there. Sparse mode's enabled. Anycast RP, loopback 60,000, which I'm like, why did you do that? I didn't ask you to do that. So. Overlay config. So here we have our receivers. We got our rendezvous points with ASM that are in the overlay. We got our sparse mode configured. We got a source that's hitting the first hop router. He sends a PIM register to the RP. Once again, it's load balanced. I'm not sure where I'm going, but I'm going to the one on the left. So that RP is going to update the peer RP via MSDP, but there's no receivers. So I'm going to send a PIM register stop back. And this process is going to go on every 3 minutes. Let's get some clients. So here comes the IGMP membership reporter, the IGMP join, up to the Fabric Edge. The Fabric Edge is going to receive that. It's going to send a PIM join star comma G to one of the RPs. And both of our RPs now have the information they need and says, hey, I got receivers downstream. I'm going to send that PIM join back to the first hop router and say, send me your multicast traffic. And here comes the multicast. So what's interesting here, and this had me scratching my head, is, okay, I have ASM in the overlay. I got some 239.10.10.10 address. What's going on in the underlay? I'm doing show IPM route VRF staff, and I'm like, okay, that looks good. But actually, the multicast is in the underlay, and it gets mapped to this 232 address. And then the intermediate nodes replicate the packets down. So we're not unicasting, we're multicast within multicast. And this is what it looks like. So here comes our stream coming in. This makes sense. I got the 192.168.201.2 as my source. And I got a 239.10.10.10 address. Once it hits the border, it encapsulates that in a VXLAN, and you can see the mapping that occurred right here. So this 239.10.10.10 address now gets mapped to 232.0.2.5. And what is this address? Anybody know? It's the RLOC of the border, right? No longer the source. So that we have an outer header and we have an inner header. And that traverses all the way down to the Fabric Edge. Looks exactly the same on that FE, and then same on the other FE, and then boom, down to the receiver. So I'm doing show IPM route VRFs, I'm doing show IPM routes, I'm doing show IPM route VRF verboses. Like, what's the mapping agent? So looking at Ceph tables, much more difficult to troubleshoot, but very efficient. Any questions? So you're running SSM, forget the loopback 60,000 in the underlay, and you're running ASM in the overlay. So you're actually got 2 control planes going on, 2 things to look at, and that's how it works. Okay, I came into an existing network. Sounds like some people were running MSDP out there already. I got RPs out there. What do? Well, You can only have one internal RP in the fabric. That's soon to change, but it's the way it is. You can only have 2 external RPs outside the fabric. That just changed like 2 weeks ago. So now we can have multiple external RPs. So one of the things that you can do is to actually peer these things with MSDP. So you can peer the internal RPs to the external RPs. It does require manual configuration, so you can use a template editor, or now called Template Hub, to do this. And you have to do it per VN or GRT mapping to the global routing table. The BU basically said, don't use internal RPs. So we're like, okay, we'll just do the external RPs and not do any MSD peering. So the only internal RP we have is that loopback 60,000 that's out there. Everything points outside the fabric, and that's the recommendation as of right now. And I just talked to the BU the other day to use external RPs. Put it on the Fusion even if you don't have one. What does the configuration look like if you need to do that? It's right here. Pretty straightforward, MSDP. You can use the template editor to build this stuff up, to do the configuration. MSDP is not that hard of a protocol to get operational. Very similar to like HSRP, VRRP to use. This was a big challenge. This still is a big challenge. This is where I need your support. I got 2 receivers in different VNs trying to pull from the same multicast source outside the fabric. In this case, my border nodes are configured as RPs. I got an eBGP handoff, and these clients are requesting this traffic. How do I make this work? There is no way to leak multicast between different VNs at this point. The only way to do it is something called multicast VPN extranet feature, and if you Google that, you'll see configs from 2003, 2006. This is the command. We were on TAC cases. They were using this on iOS XE. It's not supported. We were getting all kinds of weird stuff, and we will show you incoming interfaces with sources in the fabric, one going one direction, one going another. So we punted. We really, really, really need this feature. Lisp extranet, great feature, right? You probably heard about it this week. Shared services leaking into 2 VNs, don't even need the Fusion router, right? Trying to get rid of that Fusion router. I went up to the guy, I'm like, could we do multicast? Not supported. Nope. I was like, okay. This is great. Anybody got any 6880s lying around or Nexus 7Ks they don't want to get rid of? Because it works. So iOS, not iOS XE, okay? So this is a big thing. Think about your VNs. Think about your sources and receivers. Maybe use microsegmentation as a way. If the receiver needs to hear multicast from a source outside the fabric, we'll talk about how we did that. Okay, I'm going to pause, and I'm going to turn this over to Rashmi, and we're going to give you some gory configurations and some templates that you can use. And then we'll come back and talk about some of the enhancements.
Thank you, Jeff. Okay, Jeff took us through the bunny slopes, which I'm still training on in terms of skiing. So now let's dive off the deep end. Sorry, I just heard myself. I've been told I mix metaphors a lot, and I realized how horrifying it must seem. We are not going to dive off the mountains. We are going to go through the double black diamonds of our customer implementation so that at the end of the session, all of your implementations should seem like bunny slopes. All right, let's go with it. So top priorities for our customer. They are transportation, so I don't even need to say it's security, big challenge, and it's a must. We need zero trust environment in their network, so we need to implement Cisco TrustSec. And macro and micro segmentation, of course, again, it's obvious they need it. Okay, this is going to be the ticker tape. It's still the ticker tape for us because we are still in deployment for our customer. Emergency service traffic is critical for them, and all of that emergency critical service traffic is multicast. And that's probably why you see us presenting here today, because we are presenting challenges with multicast in SD Access. All right, so keeping those priorities in mind, we came up with a design, an SD-access fabric over a linear optical fiber network divided into 3 sites, the eastern, western, and tip fabric, and a fusion router to take care of any inter-VRF or shared services to VRF leaking. And the data center connects our fabric to the production network, and they have remote sites over microwave WANs. We will focus on the multicast part of the design today, but there are some hidden slides over there if you want to look at more details on that particular design. 2 multicast streams that we had in mind. One for the staff VRF, which carried all the emergency critical services. And there was multicast stream 2, which is for CCTV cameras. And you also see a unicast CCTV stream over there. I'll briefly touch upon it, but not go into more detail because that's not the focus for today. Okay, multicast stream 1, sources and receivers can be anywhere. IP phones, pagers, soft phones on laptops, they can all be sources and receivers. They can be within the fabric or outside the fabric. The RP for multicast stream, sorry, I wanted to use the pointer instead. I did that. Okay, so the RP for the emergency critical services is in the microwave WAN. It's literally sitting up on a hill. And multicast stream 2 has to do with CCTV cameras. The sources for CCTV can be cameras within the fabric or outside the fabric. The receiver is going to sit in the data center behind the RP or in the data center. The RP for CCTV cameras is in the data center. So that's briefly about the 2 multicast streams. We tested both of them, but we are going to focus more on multicast stream 1 today. Throughout this presentation, you will see these icons. Any icon in green is sources or receivers for multicast stream 1. Any icon in blue is sources and receivers for multicast stream 2. If the icon is in red, it's either outside the fabric, so it's in the global routing table, or you do see one funky red icon over here connected to the fabric. That's our multicast VPN extranet. So these are devices called land mobile radios scattered throughout the network. So we needed them connected to the fabric edges. They are basically analog radios sitting behind ISR 4K routers. The ISR 4Ks have routed connectivity to the access switches in the production network, and in fabric, they're connected to the fabric edges. So basically, those devices are sitting in the global routing table, but they need the stream from the staff VRF, and that is the multicast VPN extranet that we have implemented. We'll show you how shortly. Some more design details for multicast. We have any source multicast in the overlay because sources and receivers can be anywhere. We do have any source multicast in the underlay as well, which is custom config to accommodate the land mobile radios. With DNA Center, we implemented native multicast, which is source-specific multicast in the underlay. Okay, this is an important point that you need to consider for all multicast implementations. Regardless of whether you do headed replication or native multicast, you will need to create a pool for each VRF where multicast is going to be enabled. And the size of the pool, it's determined based on how big your fabric is going to be. So when I say fabric nodes, we are not taking the intermediate nodes into consideration. The borders and all the fabric edges you have will tell you what the size of the pool needs to be, because a loopback will be created from this pool by DNA Center on each fabric device for in each VRF that you're going to implement multicast in. So that's a very important thing to keep in mind. And we have routing set up on the Fusion for reachability to external rendezvous points. And we spoke about this, the land mobile radio. It's placed in the underlay and routing is set up with the fabric edge. Okay, so I spoke about the pools. Here you see an example where we have one of the fabric sites. One of the fabric sites and the two pools which are created for the two VRFs in that fabric site. And you do it in the design page of DNA Center. Okay, so now the pools are set up. We know how the multicast is going to be implemented. The next step is to implement multicast over the fabric. And there is a multicast configuration workflow. As of 2235, which is what you see up here, this is how the configuration workflow looks like. You select the site where multicast is going to be implemented. And then next step is to select what is the mode of multicast you're going to implement. We did native multicast. And then select the VRFs where multicast is going to be implemented and the type of multicast. As of 2235, which is what we have implemented for our customer, we can only do one type of multicast. It can either be ASM or SSM. We couldn't do both, but with 2353, that has changed. And then we do the multicast pool mapping for the VRF to the pool that was created for it. Configure the RPs, as in mention the IP addresses of the RPs, and then the last step would be to associate that RP with the VRF for which it will be the RP. There is one more step which is not shown here because this is the summary page of the configuration workflow. That is to select whether you're going to use an external RP or an internal RP. We did an external RP, that's why only those sections are shown. Okay, so we decided what kind of multicast implementation it was going to be, and then we ran the configuration workflow on DNA Center for the fabric side. But we do have custom configurations to take into consideration, which is what we're going to do in the next couple of slides. So this is a template that we created for the border nodes as well as the fabric edges, where we did group to RP mapping for the underlay to accommodate the LMRs. And to match that RP address statement on the VRF as well, we updated that. And that's the template that you see. And we need a similar template for the intermediate nodes so that replication for the LMRs can happen on the intermediate node as well using the group to RP mapping. Okay, so now in the next few slides, we are going to take a look at how the configuration looks like. And this will help us if you cannot enable multicast. If you have custom configuration for your multicast implementation, you can't enable multicast during LAN automation. So having an idea of how the configuration looks like will help you to create templates instead. So that's the purpose of the next few slides. So this is the configuration which is pushed by DNA Center to the fabric devices, especially to the border nodes here, when we enable the when we do the configuration of multicast for the fabric side. So you might be wondering why there are two color schemes here, one in dark blue and one in light blue. That's because I like colors a lot. Just kidding. It's because all of these configurations are pushed by DNA Center, but anything that you see in dark blue up here is the configuration which is relevant to the multicast implementation that we are doing. So loopback 4100, a loopback is created on the border node once we do the multicast config, and then PIM sparse mode is enabled on it. And on the corresponding Lisp instance, the interface, there is a transport multicast and a core group range which is configured, which associates that VRF interface with the underlying multicast group which will be used. So 232.0.0.1 is the start address, and then 1000 is the number of groups which are going to be created. So each multicast group will be associated with a corresponding SSM group in the underlay. And then whatever is in the box below, that's the configuration again pushed by DNA Center for future purposes, for layer 2 flooding, for instance. This did cause us some heartburn, and we'll get into that. Okay. And also the MSTP is configured between the border nodes. by DNA center. And this is done when we do LAN automation and we enable multicast during LAN automation. This slide is a look at the configuration from a border 2 perspective, so it's similar. Okay, this slide shows common configuration on both the borders. Multicast routing is enabled in the global routing table as well as in the VRFs. For the staff VRF and the security cameras, the RP address is configured. The static RP is configured, and the corresponding loopbacks in those two VRFs register as sources. And SSM default is enabled for the global routing table as well as the VRFs. And this slide shows you the custom configuration. I showed you templates earlier, so that's the config which is pushed when we create that template and provision the device using the template. And this slide shows you the fabric edge config. It's similar. You again see the Lisp instances for both VRFs, and the core group range is configured for them, and loopbacks created for each VRF where multicast is enabled. This is again similar to the borders. Multicast routing is enabled, SSM is enabled, and the static RPs are set on the fabric edges. And now the custom config which is pushed through the template. On the intermediate nodes, it's simpler. Multicast routing is enabled in the global routing table, and SSM default is configured. And through the template, we set up the static RP so that the LMR can have reachability to the staff VRF. Okay, this slide should show you the configuration which is common to all devices, fabric as well as the intermediate nodes. Basically, it needs to be a complete PIM domain. You need to have PIM sparse mode on all routed interfaces because we are doing multicast in the underlay with native multicast. Okay, so the configuration is done. We took a look at the config, made sure everything was okay. Next step was to test it out to make sure it works for the customer. So this was the scenario we started with, a sender in one of the fabric sites, sending out traffic to other fabric sites as well as external. But we wanted to make sure we test it out ourselves. When I say we, the Cisco CX team who was supporting the project, we wanted to make sure we test it out, make sure the control plane is fine, and we run some pings and all of that. Everything looks good before we bring in the customer, because pagers and IP phones are the sources and receivers. We wanted to take their time into consideration, make sure we make good use of the time. So how we did that testing ourselves, this slide shows you that we basically set up loopbacks on the fabric edges, simulating sources for the staff VRF. And there is also a loopback on the Fusion router, which simulates the LAN mobile radio. And then we set up the Fusion router loopback 0 as our RP so that we don't disturb the production RP. And this is what the configuration looks like. You can see the loopbacks have been configured with IGMP joins. And the important step to make sure in the fabric is to advertise that loopback in the Lisp instance. And of course, we created the static RP configs, pointed it temporarily to the loopback 0 Fusion router. And once that setup was complete, we sent a ping from the Western fabric edge to that group. Okay, this is one more thing we used. We didn't use the production multicast stream. We instead used 225001 as our group so that we don't conflict with production traffic. And we sourced it from loopback 100 because that's our source. And let's see what we found. This is the control plane output. When you enable multicast, with native multicast, this is what you see. 192.168.1.6, that's our source. So you can see the incoming interface is loopback 100. Now let's take a close look at the OIL. The outgoing interface is Lisp 0.4100, which is our Lisp instance ID for the staff VRF. And 10.19.10.5 as the next hop IP, the RLOC of the intermediate node. And 232.03.72 is the underlying SSM group, which was created, which corresponds to 225001. And you see that the tunnel is being built to 10.19.0.2. That's the border node for that fabric site. And you see the control plane looks fine. All the receivers are showing up here, and the packets are being incremented. We also took a look at the pings to check whether that's happening. We see all the loopbacks up here, so everything looked good. But we didn't want to celebrate too soon. We wanted to test as close to the real-life scenario as possible, so we started sources simultaneously in multiple fabric sites by sending another ping from one of the other fabric edges. And this is the control plane output for that test, where while we have a source in the western fabric, we also have a source in the eastern fabric. Both of them are transmitting simultaneously. This is what we see. The control plane looks fine. Not much difference compared to the previous slide, you would say. So let's take a look at the data plane. Do you see an IP missing here? 192.168.1.5. So that doesn't show up here anymore. Of course, this is a truncated output of the actual output that we saw. We were seeing that it was responding, but intermittently. So we used to not see it for a while, and then it would show up, and then it would not show up for a while. So it was very strange behavior. The control plane looked fine though, so we didn't know where to go next. So what we decided to do was now to bring the customer in and do the actual testing so we can troubleshoot the actual issues rather than wondering about whether there is a CPU punt happening or what's going on. We didn't want to get too much into that, so we started bringing in the customer endpoints, actual pagers, IP phones, and the actual multicast group, and we did the testing. So with that testing, there were 3 outstanding issues that we saw. When there is a source in the external production network transmitting to within the fabric, sometimes it was fine, but sometimes there were losses and delays, which we can't handle, shouldn't be there. The second thing that we saw was when there was a source behind the land mobile radio transmitting to a receiver in the fabric side, there was a delay or a loss. And then the third thing was source in one fabric site sending out to a receiver in another fabric site in the staff VRF, there were losses and delays. So next section, we will deal with those issues. We'll flesh them out and see what caused all of those issues. And hopefully, in your customer in your multicast implementations, you will be able to take these lessons learned and utilize them. Yeah, so I thought it would be a bunny slope. I was very confident after Jeff trained me, but yeah, all I see is that steep slope. I'm worried about what if the ski lift gets stuck midway and I'm not able to get to the top. So let's flesh that out so we can make it bunny slopes for you. The first issue, pagers which were sending traffic in the production network, we were seeing delays within the fabric side. So we started digging, we engaged TAC, and then we looked at previous TAC cases, and what we found out was there was a TAC case a few years before we started doing SD access, because pagers were seeing delays when the switchover was happening from the share tree to the source tree. So the workaround or the solution for it was to not do the switchover because pagers apparently couldn't handle that switchover. So they were asked to not do the switchover and set the SPT threshold to infinity so that any pager traffic stays on the share tree. So once we were aware of that, we went crazy with it. There were no clear guidelines on where exactly to implement the SPT threshold. So we set it everywhere. We hoped that it would solve the issue, but unfortunately not. We were still seeing those delays, and then we dug deeper and deeper, and we did a lot of troubleshooting and a lot of testing, and we came up with the conclusion was the SPT threshold needs to be set on infinity only on the last hop router. So that's what we did. Here you see a template for it. This is a template for the fabric edge because that's the last hop router. If you take a close look here though, you might be wondering why I have the template set only for the staff VRF and not for the global routing table because the LMR is connected. The reason for that is the ISR 4K is the last hop router actually for the global routing table. So we have a similar configuration in the global routing table on the ISR 4K as well. So once we did that template, that issue was resolved. We were now able to send traffic from external sources to receivers within the fabric. There were no losses or delays. The next thing we had to deal with was sending traffic from the LMRs in the fabric to receivers within the staff VRF. We were seeing losses and delays. That was because of hardware limitations. All of our fabric devices are Catalyst 9Ks, which don't have that feature. So we did do an RPF select, but next slide, we are going to look at how that loop looks like. So you see that 10.18.177.200, that's a phone, an IP phone in the staff VRF. It's sending traffic to that multicast group. And the incoming interface is supposed to be this VLAN 3020, and the outgoing interface is supposed to be VLAN 201 because it's sending traffic from the staff VRF to the LMR. However, the incoming interface that you see here is 100 gig 2049, which is the upstream interface to the Nexus 9K from the Fusion router. This is a snippet from the Fusion router. So that showed us that there were loops happening. The traffic was actually going to the Nexus 9K and then coming back, which was causing our delays and losses in transmission. So we did do RPF select as per TAC to find out if that fixed the issue, but it did not. So the only option that we had then was to remove the VRF Lite config on the Fusion router only for staff VRF. So essentially, we are putting both the LMR and all other sources and receivers on the same routing table. So we don't have extranet anymore, and it's going to work properly. We did do that. That was our solution, and it started working fine. So the two issues, major issues that we had, we resolved that. Everything was working fine. So we wanted to bring in more fabric sites and start testing them. So we did LAN automation on another fabric site, and we enabled multicast. This is the issue that we saw. So if you have any custom multicast configuration already on your fabric devices, especially on the borders, and DNA Center sees that, and you enable multicast during LAN automation, it throws an error message, and this is an example error message. So it's showing that the primary seed contains an external RP. That's the custom config that we did on the border for the LMR. And the peer seed, it's showing the Anycast RP, which was for future purposes. So we could not get around this. One of our peers actually did try to do a feature request to see if that custom config could be accommodated, but it was shut down. So the only option that we had was to not do multicast during LAN automation, take all the configurations that are going to be pushed by DNA Center and create a template and push it instead with the template. So that's what we did. We created templates. These three slides have templates for all the devices, including the intermediate nodes. We created one template which contains the custom config from earlier as well as so the important thing that is done during LAN automation is PIM sparse mode is enabled on all the routed interfaces. And also SSM default is configured in the underlay, and the Anycast RP, of course, is configured with MSTP. So we created templates, put all of that configuration together, and once we did the LAN automation, the device came up, it was added to the fabric. We also ran provisioning before adding it to the fabric and after adding it to the fabric to put all the custom configurations in place. And it's working fine. We are not seeing any issues. Touch wood. Okay, so everything was working fine again. We had a few weeks of kind of a celebration because this was months of testing together for multicast, after which we were seeing that everything was working fine. And then we decided to do some convergence testing, basically simulate a fiber failure on one of the borders. We did that, and you know what hit the fan? So we didn't know what to do, why we were seeing such issues, and then Again, a lot of troubleshooting, and this is what we found out. So basically, if there is a source in one fabric side, sending, where is that pointer? Okay, found it. There is a source connected to fabric edge in one fabric side, sending traffic to a receiver in another fabric side. It works perfectly fine. And this is how the config looks like underneath. So on the Lisp interfaces, for fabric side 2, you see core group range configured. In the SDA transit, it's the same core group which is being configured. And on border 2 as well, it's the same core group range which is being configured and used. Now, everything will work fine unless and until you introduce a second source and a second receiver in the same VRF. What happens now is border 1, any traffic which comes from source 1, it decapsulates it, encapsulates it over the SDA transit and sends it over to border 2. And similarly for border 2, any traffic which comes in from source 2, it encapsulates it over the SDA transit. The next hop is border 1. What happens because of this? There is a loop between the two fabric sites for traffic which is being sent from source and receiver within the same fabric site. So that's the cause of the losses and delays when we have sources and receivers in the same VRF sending traffic to each other between fabric sites. That was the reason we were seeing that issue. Yeah, that's me and that's Jeff. He's asking me to get up. I'm like, I'm tired. I can't do this. We didn't know where to go from there because we needed SDA transit so that we could have a consistent policy. But SDA transit is not going to support our multicast implementation with 2235. So what we came up with instead is an updated design. We removed SDA transit from the picture. We did an IP transit. But there is a big problem here. We don't have consistent policy any longer. There are localized SGTs for each fabric site. So how do we do that consistent policy? There were sessions earlier this week where this was spoken about. Basically, we do a manual CTS propagation across an IP transit, and that's how you can carry your SGTs from one site to another if you cannot do an SDA transit. So the next two slides, nothing else changed from a design perspective. We just changed the transit from SDA to IP transit. So it's eBGP handoffs to the Fusion router with this additional command on each of those handoff interfaces and on the Fusion as well. And now we want to make sure that we did do the CTS inline propagation. Technically it works, but we want to make sure it works. How do we make sure of that? We took a packet capture. So the first packet capture is on the fabric edge. For one of the packets, you see this is the inner header. Look at the SGT tag here. It's 22. And then we want to make sure that that SGT information is preserved across the transit when it exits the border. So we took the next packet capture on the egress interface of the border. So you don't see that VXLAN header anymore. What you do see is the Cisco metadata header, but it does copy that SGT information from the VXLAN header, and it does this because we have the CTS inline propagation configured. So by this, we made sure that in spite of having an IP transit, we still have consistent policy across fabric sites. And the other issues that I spoke about, apart from the SDA transit, they are still in play, and the workarounds for them are still in play. I'm not going to talk about them in this section, but yeah, so we do have some other small issues that we are trying to troubleshoot, but for the majority part, I would say that multicast is working beautifully. So it does look like bunny slope to me at the moment. With that, I'm going to hand you back to Jeff to take you through enhancements with Ghost. Thank you.
Thank you, Rashmi. So lots of challenges, right? Lots of months, lots of work, lots of attack cases, lots of what we call an internal BEMS case and so forth. But we did go through council. This design was approved. And during the process, we found that looping condition. So it was that we just didn't know. We just, with the sources and receivers everywhere, we just were not sure what was going on. So then you see 235, right? 2353 is GA now. Obviously, being a transportation customer, public safety on the network, we're not going to just upgrade to this release to see what happens. But there's definitely some fixes that are in here that we could have used. So ASM and SSM can now be configured in the overlay. So when you're going through the workflow, you'll see the box for ASM and SSM to check. So for people that do have SSM out there, you had to choose one or the other in the overlay. So that's a big enhancement. The ability to map RPs to different group addresses. You saw the templates and what we had to do. 2 external RPs. Come on, guys, what are you doing here? You know, we got unicast working, we got bum under control, Radio Perman's, having a nut. She's flipping out because Spanning Tree is getting under control with all this control plane stuff, right? So, yeah, it's old school Cisco people, right, from radio. And Bo's probably like, Bo Williamson's probably like, what did you guys do to my multicast? So, but the ability to do that, per VN too, so you can have different RPs to different group addresses. And, but the one thing is the number of maximum internal RPs is still 1. So like I said, the B recommendation, put it external. They are going to enhance that, so maybe internal would be the way to go, but having 1 internal RP, you might see slides with 2, but MSDP, 1 address, right, across multiple VNs from the multicast pool that you use. Still really not flexible. And to do the leaking, you really need to get this thing outside the fabric. I mean, obviously, if Lisp extranet could have a feature, if multicast VPN extranet could be used, right? There's things that can help leak. We had to use the global routing table to leak into the staff VRF, so it's very limited to what you can do. So you really need to design your VNs based on your multicast and who needs to receive traffic and who needs to source traffic, and you need to think about that and understand that. Considerations. So in the workflow, when you do the RP to group mapping, there's going to be a subnet mask there. You can't use a /32. It's going to be fixed. It's just one of those things where we just tried it the other night. /30, /31 works. I know there's a couple addresses that could be used there. But when you're doing that mapping, so TAC doesn't get a call, your local SE doesn't get a call, just use /30 or /31. It is in the release. This is going to be expanded, right, this internal RP. Underlay multicast must be manually configured. So they fixed the looping condition, but you still need to do the handoff, either using template editor or manually do it. It's not going to be done in LAN automation. And the other thing to think about is you need to map all the groups to an RP. So whatever groups you're interested in, make sure there's an RP map. There's not a catch-all or default RP that is there. That is something to be fixed of, okay, I'm interested in these RPs to these groups, and then everything else can go to this RP. You got to make sure you have all the RPs mapped to a group at this point. Multicast and SDA transit, right? We thought we were golden. We thought I got VXLAN headers. This is the right design. SDA Council approved me. And we fought and fought and fought. We really thought we had something here. We thought it was going to work. And we're like, what is going on with this? And there's looping conditions. We don't know why they're occurring, but we know there's looping conditions. So like Rashmi said, they've resolved this in 2.3.5. And there's a new command. And what's funny about this command is I do have a little video that we were going to play for you, but we decided, you can go do that. It's kind of boring, actually. There's this checkbox in the Fabric sites in the SDA transit. That's all you do is check the checkbox. You don't even specify that command there. And what it does is it just picks a different address. So here was the looping condition, right? We had 232.0.0.100. Now we're using this different address in the SDA transit of 232.11 that you'll see there. And so with that in place, it fixes the looping condition that has when you have multiple sources and receivers in different Fabric sites. They can be in different VRFs too. We basically changed the one slide because we were seeing this in the same VRF as well. That's the link if you want to see the new interface. Question? Yes, and I'm going to get to that, but I'll tell you, it's 17.10. But yeah, I do have that. So you can go to this YouTube link and you can see the new interface. Literally, it just came out 2 weeks ago. So the release actually came out in February, then was pulled back in March and was just released 2 weeks ago. So there's not much. You're not configuring the range at all. You're just checking a checkbox, and it'll push out the configuration, and that'll show up there for the SDA transit. So it'd be nice to go back to transit, get my VXLAN headers back, not to have to do manual truss stack and everything that we plan to do, but eventually we'll get there. But IP transit's been working out really well for us. Some commands. How do I troubleshoot this? These are a lot of the commands that we use. Verbose is key, counts, right? Verbose is that mapping from the original multicast address in the overlay to the underlay SSM address is key. You're going to have to do show IPM routes on the VRF. You're going to have to do show IPM routes in the underlay as well. And you're going to have to look at the incoming interfaces, the outgoing interfaces. Obviously, all the flags are still the same, right? The join bit, the prune bit, all those things are going on. I always like to do this. What the heck is all this? This numbering scheme actually there is some rhyme and reason to this stuff. So loopback numbering, there's our 60,000 for layer 2 flooding. The 1,000 series are going to be your Anycast addresses. Your 4,000 are your Lisp instance IDs tied to that. And if you're doing any sort of L2 borders, the 8,000 series is used for that. Summary. Some key takeaways. If you're doing native multicast and you have this RP to group mapping, just don't check that checkbox. It starts barking back at you. You saw the message, right? So just go and just run the LAN automation. LAN automation works really well, bringing on devices, upgrading code, and then go apply the templates. Now you have some templates to use. If you're running 235, then you'll be good with the RP to group mappings. It's very flexible. I don't think there's a limit. Everybody's asked that question. I don't see the limit. The interface is very straightforward. That's out there. If you want to grab your local SE, there's actually a dCloud demo of 235, an instant demo if you want to walk through that and actually see what those screenshots look like that are out there. SDA Transit, not supported in our release, fully supported in 235. I don't know. It's been out there 2 weeks. You know how that is, right? So I'm sure some testing has been done, but obviously our customer network is quite large. It's very complex. So we would have to upgrade and see that and see if that command actually does it. The other problem was we were running 17.6.4 code, and those are in the hidden slides. We give you all the code, the switches, so that you knew the DNAC version, the code that's out there. We're not jumping to 17.10. That was just something that we did not want to do. Understand the existing environment. Understand the endpoints, understand the IGMP, understand do I need ASM or SSM, understand do I need head-end or native. These are all things to take into consideration. Understand if you need paging. And if you have paging working without that SPT infinity threshold, good for you, because it seems to be an issue on this particular customer's network. We have seen it other places as well, but this one, it was ripping havoc on us on this because it would just start working, and then it would just stop working. And we're like, man, just start working. Once the tree got built again, and we even tried clearing MRoute tables. Sometimes we did that, and it just worked. I'm like, what is going on here? So we weren't sure without knowing about the looping condition and where the source was, where the receiver was. We didn't know about that, so we were trying to figure out what the heck was going on with this. Test every endpoint. Understand the endpoint. That's a big thing. That's a big thing from ICE perspective too. Just SGT in general, profiling. Where am I putting it? What SGT tag? What contract do I want to, right? There are so many in the IoT world, in the transportation world, these aren't really smart devices. They're not logging in with 802.1x, right? They might be doing Mac-based profiling. But understanding how they work, what do they talk to? We had a DVR pop up on us the other day. Like, we didn't test this, but we have a DVR, and this client and staff needs to talk to the DVR, and that's in the security camera VN. I was like, okay, luckily it was unicast. So if it was multicast, we'd be like, oh boy, here we go again, right? So, like I said, look for delays. If you have paging, this man may or may not be your friend. It certainly wasn't ours. But setting that, and I've seen multicast. I took Bo's class many, many moons ago. There is a threshold and amount of traffic that you can set with this command. The recommendation is either leave it go from the shared to the source tree, or you turn it off, infinity. No in between. So you can look for, okay, 3 mega traffic, I'm going to cut from the shared to the source, right? You can do things like that. I would only advise to do that if TAC was telling you to do that. There's the 1710 code. And some of those other features on RP to group mappings and things like that, there's other code, I think 17.8 I've heard that's supported, but I would go, if you want to try it, I would go with 1710 because the looping condition is the big one. And if you're running Lisp BGP, hopefully not. We were lucky on this one. We were advised to do pub sub right out of the gate, so that's what we did. And pub sub, if you've taken any Lisp sessions this week, have a lot of features on the default border, the backup border, the Lisp extranet, all those good features are in there. So that's a little checkbox too, is try to stay away from Lisp BGP. It's really ugly. The support on pub sub is much better and much cleaner. So I'd like to thank the customer. Like I said, my customer is in the room here because they were very patient with us, with TAC, with the BU, on getting to where we did and helping us develop this presentation. And this is a whole host of people from the business unit to the architecture team and so forth that I would like to thank as well. Obviously, anybody get socks yet, or cool socks? Good socks? Question or socks? Fill out your surveys. We really appreciate that. I think I haven't been to Cisco Live since 2019, but I thought the sessions were really good this week. I love that. To me, I tell my customers, like, go to the on-demand sessions, watch these sessions. You learn so much. Unfortunately, a lot of our stuff is marketing, but commands, right? Configuration, what happens. I think Cisco Live is so valuable, right? And I don't think you could do any Meet the Engineer sessions unless you talk to me right now. There's your on-demand, and thank you very much. And like I said, fill out the surveys.